Hello, my name is Mahdi Al-Husseini in the class 5460 Educational Technology, and this video is essentially going to serve as our intermediate milestone 2. Just a little bit of background before we get started. So I'm actually working on this project with a fellow classmate, who in this case is my older brother, Muhammad Al-Husseini. So we're both in the same program, the same course, and what we decided to do essentially, to give you the pith of what our project is we decided to undergo a development-based project in which we would support and assist high school students as they develop an autonomous vehicle, specifically an autonomous soapbox car, to be raced at an annual soapbox race run by Google in our hometown, and that is in Douglasville, Georgia. And the name of that event is the Georgia Gravity Games. And essentially, the students racing their autonomous vehicle, which we would support them and assist them with, serves as the culmination of our project. And for that reason, we actually have already completed our project. The race day itself was on November 2nd, again in Douglasville, Georgia. The students did very well. In fact, they actually placed first in the autonomous category. And I'll get a little bit to that later. But our impetus for this was actually specifically to support our high school cousin, Salah Al-Husseini, who's attending Douglas County High School. He is a potential future Yellow Jacket, so he's eagerly awaiting to hear back on his application, and he's someone who's always been kind of interested in engineering and the way the world works in general. And this project was for us a way to support that and to really help him dig into, along with some of his classmates, to dig into what exactly an autonomous vehicle is. And of course, applying some of the computer science background that we've developed throughout the OMSCS program, we ended up going with a computer vision based design, and that of course specifically supports my specialty in the OMSCS program, which is computational perception robotics. And so in that case, this project really did have a little bit of everything. And of course, at the end of the day, it is an ed tech project, and the idea was, of course, to educate students as to the nature of these projects, which can be kind of complex at times, but also to give them a sense of some of the different fields involved with the development of an autonomous car. The beauty of robotics is that it isn't really just one field, and in fact it's multiple fields to include mechanical engineering, electrical engineering, computer science, to name a few. And so I just want to briefly talk about some of the progress that's been made over the course of the past few weeks. Again, this project is technically in completion. So just to begin, as you can see on the screen in front of me, we've got the Tensor Tigers logo right there. One of the really neat things is actually have a 501c3 nonprofit organization that we've pretty much put Tensor Tigers under as a part of, and that's kind of helped us get some of the funding. We're actually funded by Walmart, which is pretty neat, and there's some other grant applications out, but that's essentially paid for the expensive aspects of the autonomous soapbox car, which in total I would say has run up to about $2,000. But as it states there, we consider this this is a 501c3 nonprofit organization, and it's dedicated to supporting STEM education for K through 12 and undergraduate students through the development of autonomous soapbox cars. So in the future, and again, this project is in completion, and so some of what I'll be doing today is looking to the future, is to actually involve undergraduate students at Georgia Tech who are on campus, and to bring them to Douglas County and to Douglas County High School specifically, to support different teams who might be developing these autonomous soapbox cars for next year's Georgia Gravity Games, still run by Google. We're excited to see where it goes. Again, we adopted a computer vision based approach this time around, but we think in the future you can do more of an inertial navigation system, you can do a GPS system, you can do a system based on using LiDAR, a system using ultrasonic sensors. So there's a number of opportunities, and students will really get a chance to work on whatever approach they think is the most interesting. And so just to continue down along here, so here you can see some of the photos. Oh, and this is just a web page I quickly developed on my personal website. But you're just going to go through some of these photos. So this is yours truly. Hi, that's me. This is our Tensor Tiger soapbox car. This is my older brother, who again is part of this project and in this class. And that right there is my high school cousin, really who was our first student. And it was really, he was our first student in the sense of developing what we hope to in the future be some kind of curriculum. Now, for the purposes of this class, just based on time restrictions and whatnot, each of us have put over 150 hours into this project so far, and that's only been on the development side. But in the future, some of the content that we want to come up with has its roots in working with our first student, and that's Salah right over there. And that's just the trophy in our hand that we won from being first at the Georgia Gravity Games, and some of our signatures there. So it's all pretty neat. You can actually see a picture here of us, and this is me, and that's my brother, and we're supporting and doing some fine-tuning on the test on the device itself before race day. Now, certainly, of course, the students helped develop this, but there were certain aspects of the car that were just too complicated for high school students, and that involved, for example, tuning the parameters on the PID loop, which is what we are doing in this instance here. Here's just another photo of the car. You can see some status LEDs. It's really neat because the event itself, the Georgia Gravity Games, brings literally thousands of folks into the city to race cars, and the vast majority of the soapbox cars there are what you would expect in a normal soapbox race. They're driven by humans and specifically kids. But the cool part about that is the nature of the event was such that students were incredibly interested to learn about this autonomous soapbox car that they see in their midst, and students from all over, not only Douglas County, but really all over the state, had a ton of questions for us, and it was really wonderful in the sense that we could teach them a little bit about some of the work that Salah and ourselves committed to in the course of this project. Here's again is another picture. This is yours truly, Salah, Muhammad, rocking the Georgia Tech gear. Another photo of us there. Here's really a chance for you to see some of the internal aspects of the car. You've got 3 battery packs there, 2 of which are essentially lithium batteries. I believe the third is actually lithium as well, but I'd have to double check. There are really 2 systems in this car. One is a steering system and one is a braking system. The braking system effectively uses a linear actuator that you can see there, and that compresses the spring with a brake pad on the underside. And then the other side, we've got the steering system, and that's a little bit more complicated. There we've got a Raspberry Pi, which is really serving as our main computer, but that is actually connected serially to an ESP8266, which I'm a big fan of, but effectively it's a microcontroller board that has a number of different capabilities to include Wi-Fi and to allow over-the-air programming. But the 8266, is effectively serving as a controller. So on the Raspberry Pi, we run the machine learning code. On the 8266, we really pass commands to the actuators of the vehicle. There's some other things here too. You might notice here we've got a high voltage power supply that's adjustable, and that essentially feeds the 12 volts from the battery pack, basically steps it down. It's serving as a buck converter in this case to about 7.6 volts, which is powering a servo. And you can see the servo there. It's actually embedded into the wooden base of this car, but that is actually directly controlling the wheels, and of course there's steering there. So the general idea with the steering aspect of this is that the Raspberry Pi is connected to a camera, which is generally right here in the front of the car, that sees cones, and then based on the location of those cones, it'll pass information through a PID loop that feeds steering information to the 8266, serving as a controller, which passes that data on through, I believe it's PWM control, to the servo, which moves effectively these wheels to the left or to the right, orients them to the left, to the right, based on what's needed to ensure that we don't intersect with those cones. So that's kind of the technical aspect in a nutshell. There's more there involved. You'll notice there's actually a H-bridge configuration here for the actuator. There's also a remote relay system that allows us to do a kill switch. Of course, these LEDs are also powered individually. So there's some more electrical aspects here involved as well, but that's kind of the gist of what this project was. We did some testing, of course, in a garage to start. There's some more photos here just of the device itself. That's my dad. Hi, Dad. He definitely came out and supported us, so we appreciate it. But the other reason I included this image is actually because you can see the way it works is the cars are basically set up here, and then the gate lowers, and then the cars effectively race down this hill. It's hard to say what the angle is on this off the top of my head, but it's fairly significant. Of course, all these cars being soapbox cars are powered by gravity. Here's a really cool photo. So after, of course, we won the Georgia Gravity Games in the autonomous division, we actually went back to Salah's high school, and Salah himself actually gave a presentation to the class. I was there, but mostly just to take photos and answer some questions. But Salah actually gave a very thorough and pretty impressive presentation about the device he developed. And here you can see him presenting one slide about the power converters. So that's the high voltage power supply I was talking about. But there's actually also a couple of other converters as well that are more defined in terms of their output voltages. But that was a very neat opportunity. And here you can see another picture. I really love this one. I'm over here. This is Salah. There's our car. You got the green status LED, and of course all the students who are available to listen to the presentation. And there you can actually see some of the video I'm about to show you of our car during race day. So very, very cool stuff all around. Just to close out this particular web page, I also basically wrote an article for the Douglas County Sentinel. You can see right there on how we basically developed our car. And there I am. Hi, it's me. Very flattering, I know. And this was neat because it was and we actually released this. It coincided with when the event came out, or when the event happened. But it was cool because, sure, we could limit the nature of our EdTech project to K through 12, but I think it's important that you open it up to the entirety of the community, and that's what this particular article that I wrote up was intended to do, and I think it was successful in that regard. Other than that, this is also from the Sentinel. This is basically after the race, and so yeah, this is Bryan Academy is one of the teams there, did very well. And then on the second page, which is right here, you actually see us again. So we're here again in the newspaper again. It says the Douglas County High School team, Tensor Tigers, won the autonomous class, Saturday's Georgia Gravity Games. Hi, Slaw, and Mo. That's us right there. So very cool stuff. Very excited. And again, Walmart was our sponsor and paid for essentially all the material aspects of this project. And so then I would be amiss if I didn't show you the car itself. So we didn't actually finish. About a minute. So there's the car. There's the law. I'm back here somewhere. I got the laptop in my hand. So we have this set up so it's constantly streaming data wirelessly back to the laptop. We actually had a hotspot with us. That was kind of cool. Had a hotspot, so the car itself and my laptop were both connected to that wireless hotspot, so that we could constantly be receiving data from the car even as it races. Oh, there I am. Yep, you see me with the laptop in my hand. Yeah, how cool is this? Hold on, let's full screen it. I have to tell you, just personally, I was nervous as all hell. Because we had done some very basic testing, but nothing like this. But, there it goes. So it did its job. You can see it actually steers out of the way. And what we had, and you'll see it here. So we got about halfway down. And what ended up happening actually wasn't a software glitch, wasn't a failure of tuning. We actually had a mechanical failure. One of the wires that runs back to the car itself actually didn't snap, but one of the fasteners came loose, and the car just veered hard right because, of course, the tension was no longer there. So it's a shame that what really it came down to was just a failure to fasten a wire. But we're very encouraged, and we think looking at some of the data that we received, again, we were getting data from the car throughout the race. We actually think it probably would have finished the entirety of the race, and we hope when we come back next year for the race, we'll be able to complete it. So again, and let's see, let's not worry about that. So that pretty much concludes the entirety of the intermediate milestone 2. If there are any questions, we'd love to take them. We actually put a post up with one of the images, this image right here. Yeah, we put a post up on Piazza. So if you want to bring up anything in a public forum, I would be happy to address it there. But otherwise, thank you for listening. I hope you enjoyed it. I hope it was kind of neat. If you want to email me directly, please feel free to do so. My email is right there. And again, thanks so much.